Here, let's check this one out, sir. First things we're going to do, because we have this mess going on, we have a GCF here is 4. So let's factor out a 4 from both sides of this, right? So it's going to give me x squared minus 3x minus 2 equal to 0. Okay, so I'm just factoring out the 4 from each term in that trinomial, and 4 doesn't equal 0, so we don't even have to really think about it, right? So really we have x squared minus 3x minus 2 equal to 0. Now, if we try to factor this out, this is not factorable. There's nothing we can do there, and we're kind of asked to complete the square anyway. So what I'm going to do, I'm going to add 2 to both sides because I don't really want a trinomial on the left side, right? I want a binomial because how this works, if I want to pick some value that I can add to this so that I get a perfect square trinomial, because that's easy to factor and it's kind of what we're asked to do, right? So how we do that is I take the middle coefficient, which is negative 3. It's always the coefficient in front of the x. So we take negative 3, we take half of it, and then we square it. Here it's a fraction, but that's okay. Remember, when we square a fraction, we square the numerator. So negative 3 squared is 9, and we square the denominator, 2 squared, which is 4. And I'm basically just going to add 9 over 4 to both sides. Now remember, I got to add to both sides, otherwise we won't have an equation, right? So don't forget about that. And what I've just done now, let me make some room here. What I've just done now is I've made a perfect square trinomial. How we can factor a perfect square trinomial, if you forget, is we make a set of brackets and we square it. I take the left number, the left-hand term, which is x squared, and I take the square root of that. So the square root of x squared is x. That goes in the left-hand side of the bracket because it's the left-hand term. And we'll take the square root of 9 over 4. Now 9 and 4 are both perfect squares, of course, right? We kind of designed it that way. So when I take the square root of it, we just take the square root of the top and the bottom. So the square root of 9 is 3. Square root of 4 is 2, so 3 halves is going to be our square root of that term. Then I look at the middle term. Here it's a negative, so I put a negative right here. If this was a positive term, I just put a positive right here, and we've actually just factored that out now. Over here, this is 2 over 1. I'm going to do some fractions here. Let's multiply top and bottom here by 4. So 1 times 4 is 4, 2 times 4 is 8, and when I add that together, I'm going to get 17 over 4. Okay? Things are happening now. This is exciting. Let's make some more room. Okay. What I'm going to do now, because I still want to solve for x, is I'm going to take the square root of both sides. Now, what happens here on the left side is the square root is going to cancel this square here. This all goes away, so there's no need to FOIL this out or anything like that. I'm just left with x minus 3 halves. That's going to equal over here, this is plus or minus, because whenever we take the square root of both sides of an equation, unless you're canceling, you're going to have two values. So here on the left, it all canceled. I'm not going to have like plus or minus x minus 3 halves. It doesn't work out. When you cancel, it's just gone. But over here, I'm not canceling, so I have to also include a plus or a minus. We're going to get two values here, okay? That's going to be like plus or minus the square root of 17 over the square root of 4. Now remember, with the quotient rule with square roots and all that stuff, you can square root top and bottom, or here, there is no square root for 17 like it's a prime number, but I can take the square root of 4, so I can simplify this on this side to be plus or minus the square root of 17 over 2. Okay, because I can take the square root of 4, that's 2, we might as well go ahead and do that, right? That might be where they lost you to. I know the book skips across that a fair bit. So we have x minus 3 halves equals plus or minus root 17 over 2. We'll do a bit of algebra now. We'll add 3 halves to both sides. 3 halves. Now you might be tempted to combine numerators here, but remember these are two different species of numbers. This is a radical, a decimal that goes forever, and this is just a nice whole natural number, 3. So don't do that, okay? This is all gone. And we can kind of separate this out a little bit now. So x is going to equal, I always like to put the negative first, so I would call this negative root 17 over 2 plus 3 halves, and then comma, and watch how you enter all this stuff, where your comma can't be down here, make sure you arrow key 1 on the right to get it over here, and then we're just going to have the positive of that, positive 17, positive root 17 over 2 plus 3 halves. Okay? Now I know these are exact values, but you could blast these into a graphing calculator and it would approximate it. These are the locations of the x. So if we took this quadratic up here and we graphed it right out, we would have two x-intercepts. The line of that graph would cross the x-axis at these 2 points right here. One at this one and one over at this one. It wouldn't be an exact value like this is, so this is kind of the cooler way to go, but a graph calculator, as I said, would round that off. All right, buddy, so I hope that helps. Let me know if it doesn't.